I think I gave you just a moment ago the link to the Angry Birds. Really kind of shows you just how flexible the parabola is. It models a lot of phenomena wonderfully. So first thing first, I'm going to flip this upside down by playing around with the coefficient here. And then I'm going to move it to the right and then up. And I got a pretty good fit there, I think. So, I don't know, you guys getting kind of similar parameters? Negative 0.12, 2.1, and 4.4. Somewhere close to that, I'm guessing. All right, so nice. Parabolas are really, really flexible, and I'm going to want to do a lot of work with those. So let's take a look at what we got here. It says, what's the vertex? What are the x and y intercepts? What's the axis of symmetry? Let's take a look at this function, y equals 3 times x minus 8 squared minus 5, and realize that it's really a very shifted and translated graph from the graph of y equals x squared. Now the first thing I'll do is I'll put a 3 in front of that graph. What do you think that 3 is going to do to the graph compared to the graph of y equals x squared? Yeah, it's going to stretch it. It's going to pull it away from the x-axis. So that's what we're going to see right here. Pulls it away from the x-axis. Okay, nice. Now the next thing I'll do is I'll look at the graph of y equals 3 times x minus 8 squared. What's this going to do?
Move it 8 to the right.
It's going to move it to the right. Nicely done. So instead of a vertex at 0, 0, now you've got a vertex at 8 and 0. Great, let's shut this one off and let's look at one last change here. 3 times x minus 8 squared, this time minus 5.
Move it down by 5.
Moves it down by 5. So you've got a vertex here, bang, and then you've got x-intercepts here and here. If you want to see the y-intercept, you're going to have to do a little bit of work. You have to kind of scroll in. The y-intercept doesn't come for a while. Look at that, it's way up here, 187. Wow. What if you're asked to find these things or at least show your work? I have no problem with you guys checking yourself on decimals. I encourage that. But if you actually have to show your work, then the very least that I hope for you and expect from you is you can kind of look at this and determine the vertex just by looking at it. Now, how are you going to do that?
Is H and K?
Yeah, just your h and k if you're thinking of things in the basic form of x minus h squared plus k. H and k would be your vertex. So in this case, the vertex is at where?
8, negative 5.
Perfect. 8, negative 5. That's your vertex. That's something that I hope you get comfortable just reading right off of the graph, or the equation, I should say. Let's start with the easy part. If you want to find the y-intercept, how are you going to do that? You want
0 for x.
All right. Thank you, Hamza. So you're going to plug in 0 for x. That's going to take a little bit of work. So we're going to set x equals 0. And let's take a look. That's going to be y equals 3 times 0 minus 8 squared minus 5, which is 3 times 64 minus 5. 192 minus 5 is 187. So if you're keeping track of these points, I've got 8, negative 5 is your vertex, 0 and 187 is your y-intercept. How are you going to find the x-intercepts? Good question. How do you find the x-intercepts? Yep, you're going to set y equal to 0. So x-intercepts, set y equals 0. So this is going to be 0 equals 3 times x minus 8 squared minus 5. Let me make a suggestion here for you. Because you've got this in this completed square form, let's take advantage of that. I'm going to move the 5 to the other side. 5 equals 3 times x minus 8 squared. Then I'm going to divide by 3. Why do you think I did that? It's a good question. Why did I do that? What am I setting myself up for?
Use the square root property.
Yeah, you can use the square root property here, right? So if I take the square root, I'll get plus or minus the square root of 5/3 equals x minus 8. Notice that there's two solutions here. There's the positive solution and the negative solution. Finally, I'll move the 8 to the other side and get 8 plus or minus the square root of 5/3 equals x. For this test, you do not have to rationalize that. You don't have to write it as the square root of 15 divided by 3. That's pretty good. Let's just kind of verify that that's actually the right answer. So how could I do that? Well, I could calculate the square root of, or 8 minus the square root of 5 divided by 3. Make sure that that's one of my x-intercepts. So I should see an x-intercept at about 6.709. Let's take a look at our graph and make sure that we get that. Perfect, 6.709. If you want the positive root, let me show you kind of a quick trick here. If you hit the second key and then the enter key, it'll bring up your previous calculation. And all you got to do is go back and replace the minus with a plus. And there you go, 9.29. That's our other root. Be careful on WebAssign. If it asks you to solve for the roots, do you think it's looking for the decimal value or is it looking for the exact value? If it just says, you know, find the roots of this parabola. It's looking for the exact value, so it's looking for this. Now, you can check yourself this way, but if it's asking for an exact value, then it wants this. You're going to have to list them with commas. It doesn't do the plus or minus, which I find annoying. It'd be nice if it did. So you'd list 8 minus the square root of 5/3, comma 8 plus the square root of 5/3. If it says round your answer to such and such decimal place, that's the time you can use a decimal approximation. But unless it tells you to round, don't round. Okay. This was a nice problem to start with because of the form of this. Somebody had already completed the square for you. It was in that nice, neat form up here. And that makes things easy to work with. So sometimes what you're going to have to do is complete the square for me. You're going to have to do that work for me to put it in this form. So let's take a look at what that is and take a look at a lot of other things as well. Y equals negative x squared plus 4x minus 3. This isn't exactly in the right form just yet. In fact, you know what? I think I'm going to do this one over here. So this is example B. Y equals negative x squared plus 4x plus 3. So the first thing I want to do is put it in that form. I'm going to move the 3 to the other side just to get it out of my way and look at y equals negative x squared plus 4x.
I think it's minus 3.
Is it a minus 3? Okay, thank you. Then that would make it a plus 3 over here. Let me see, where's my Photoshop? Photoshop. There we go. Thank you. Now, completing the square, that's something that maybe you remember, maybe you don't. So let me go through that carefully. If I had x squared plus 8x plus something, and I wanted to convert that into a perfect square, the first thing you're going to have to do is take half of that middle coefficient. So half of 8 is 4. The second thing you want to do is square that. 4 squared is 16. So 16 is the number that would complete the square. So that 16 goes here. What happens with the 4? Well, the 4 helps us out over here. You end up with x plus 4. So when you complete the square, you're actually going to use both of those numbers. Now there's one thing that isn't really visible in this example here, this reminder, and that is the coefficient of x squared has to be 1. You have to have a 1 out in front of this in order to complete the square like we just did. If you don't, then you got to make it a 1. So in our case, I can make this a 1 by factoring out a negative. Negative, then x squared minus 4x plus something. Now I got to figure out what that something is. All I did is I factored out the negative. So looking inside, I'm going to do 2 steps to complete the square. I got to take half of what number?
4.
Almost.
Negative.
Half of negative 4 is negative 2. And what am I going to do with that negative 2? Square it. That gives me a 4. That 4 fits in right here. So it's going to be x squared minus 4x plus 4. Now it'd be tempting to say, oh, well, I'll add 4 to both sides. Not quite. By putting a 4 here, how have we changed the right-hand side? Have we added 4 to the right-hand side? Is that the net effect? Or have we done something else?
Square.
It will become a nice perfect square at the moment, or in a moment, but by putting a 4 here, what's the net effect to the right-hand side? Have I added 4 to the right-hand side, or done something else?
Would you subtract the 4?
Yeah, because you got this negative out front here. Negative times 4 gives you negative 4. So by putting this there, I've effectively subtracted 4 from the right-hand side. And if I subtract 4 from the right-hand side, Jay, what else do I have to do on the left-hand side?
Subtract 4.
Subtract 4. Perfect. Thank you. So on the left-hand side, 4 from 3 gives me negative 1. So I'll get y minus 1 on the left-hand side equals the negative of something squared on the right-hand side. So what is that thing that I square?
X minus 2.
Nice. Thank you. X minus 2. Remember, that minus 2 comes from our work up here. So it's going to be x minus 2. Beautiful. Now that I've got that all taken care of, let me move the 1 back to the right-hand side. Y equals negative x minus 2 squared plus 1. Yay. Whew. A lot of work there. A lot of work. But that's the form that I want it in. I'll probably give you an exam problem where I say, complete the square. Put it in this form. This is one of a couple ways you can do this.
So is that just to get it in the parentheses, x
That's
minus some number, parentheses squared form? Like,
that's just to put it in this form.
Okay.
y equals a times x minus h squared
Okay.
plus k. But the benefit here, Joe, is that I can look at this and determine the vertex. X and y, vertex. You should be able to look at this and say, oh, here's what the vertex is. And I'll give you a second or two to look at that and then weigh in with the vertex. In fact, let's see, Randall online, or excuse me, James online, maybe you can weigh in with the vertex. Or would that be? You can either type it in the chat or just tell it to me. Looks like you're muted, so you can tell me. All right, awesome. So where's the vertex going to be? You can start by looking inside the parentheses. What value of x would make that equal to 0? What value of x would I put in here to make this term 0? 2, thank you. Now if I put in a 2 here, this whole term disappears because I get 0 and 0 squared is still 0, minus 0 is still 0. What do I get for y when I put in x equal 2? If that all disappeared, what would be left for y?
1.
1. So there's your vertex. Done. There's a couple other things we're going to want to find in terms of this problem. I'm going to want to find, for instance, let's see, the y-intercept. How do you find the y-intercept?
Set x to 0.
Set x equals 0. Let me point out something for you. You've got two different expressions here. This one in pink, this one in orange. Which one looks easier to work with if you're going to substitute in x equals 0?
The first one.
Yeah, I think the first one, right? Can you kind of read off what y will be if you plug in x equals 0 here? If you plug in a 0, that's 0, that's 0, you're just left with -3. So spot on. I would use the top one. 0, -3 for the y-intercept. For the x-intercepts, you've got your choice. This one or this one. You know, both of them have their pluses and minuses. But let me practice with this one a little bit more. I like that idea that we did with the last one. So if we want to find the x-intercepts, we're going to set y equal to 0. So it's going to be 0 equals negative of x minus 2 squared plus 1. Let me make our life a little bit easier by being a little bit more clever in getting the squared term by itself. I'm going to move the squared term to the left-hand side of this. Somebody tell me why I'm doing it that way instead of moving the negative or moving the 1 to the other side.
Get rid of the negative.
Say again?
To get rid of the negative.
Perfect. This gets rid of the negative here. So that's going to be x minus 2 squared equals 1. Okay. Now it's just a square root property. Square root of x minus 2 squared equals plus or minus square root of 1. X minus 2 equals plus or minus 1. You've got two problems to fidget with. X minus 2 equals 1, which means x equals 3. Or the negative case is x minus 2 equals negative 1. And if I add 2 here, I get x equals 1. So 0 for y goes with 3 for x, or negative, or excuse me, 3 for x or 1 for x. Bam. By the way, what's that negative tell you about the shape of your graph?
Upside down.
Yeah, it opens down. Nice. So let's see if we can't graph this. Just kind of draw a quick little sketch here. When you're doing these freehand, just try and make sure that your tick marks are evenly spaced. If they're not, it'll kind of throw your graph off a little bit. So I've got a vertex at 2 and 1. So let's put that, let's see. Let's put that up here, 2 and 1. I've got a y-intercept here at -3. And then x-intercepts at 3 and 1. Yeah. Like that. There's a few other things I can ask you for on this problem. So this is the point 2 and 1. There's something interesting about the graph of a parabola, and that is they have a line of symmetry or an axis of symmetry. So in this case, your axis of symmetry is the line that goes through the vertex. What's the equation of that vertical line?
1.
All right. I wouldn't accept 1 or 2 as an answer. X equal 2. Good. Because what I'm looking for is an equation. And the reason I get a little bit picky on this is because y equals 2 is much different than x equal 2. X equal 2 is a vertical line. Y equals 2 is a horizontal line. A number by itself is not an equation. I need an equation. So let's finish this up with one last idea, which is your domain and range. So what's our domain?
Infinity to infinity.
Awesome, thanks Nate. -infinity to infinity. And Ben, online, what's the range? Lowest to highest. Nice. -infinity to 1, bracket or parenthesis on the 1. Bracket, nice. That's a nice little detail that will earn you an extra point is if you have that correct there. Thank you, gentlemen. All right, a lot of work there on this first example. I'm hoping that they're gonna go faster as we move through these. Comments or questions on example B?
This was on example B.
All example B, yep. Yeah, don't worry, we got like 8 more of these. I am gonna make a few comments in terms of trying to make this a little bit easier for us. So
Can you find the vertex with the quadratic formula?
you can't find the vertex with a quadratic formula, so you're kind of leading me to a place I want to go anyways with that question. Let me give you an alternative, a couple alternatives to the vertex. And basically what this is going to end up happening is that we're only going to do 2 examples of these kinds of problems, and you're going to have to get a lot out of them. So there's a formula for the x coordinate of the vertex for y equals ax squared plus bx plus c. Now, if this were a calculus class, this would be like a 2-second proof. In this class, yeah, it'd be a longer proof, but I'm not going to prove it to you. I'm just going to give it to you. The x coordinate of your vertex is given by -b over 2 times a. And that's it. So how does that work? So for example, our last problem was y equals -x squared plus 4x minus 3. So if I wanted to find the vertex with that formula, I'd have to fill in this much. The negative of b divided by 2 times A. All right. What's the value of B? Caitlin? What do you think the value of B would be here? So B is the coefficient of X, A is the coefficient of X squared. So negative of 4 divided by 2 times what?
-1.
Negative 1. So it's important to get both those negatives in there, right? So that you get negative 4 over negative 2, which gives you a 2. Johan, it's getting overwhelming?
Yeah.
Okay. But stop me if you have a question, please.
Yeah.
So that's your X coordinate. How am I going to find the Y coordinate?
Plug in your
You
tape
plug in.
You plug in the 2. Negative of 2 squared plus 4 times 2 minus 3.
Oh, that's right.
That would give you negative 4 plus 8 minus 3 is 1. So there you go. 2 and 1. Don't worry, they're guaranteed to not shatter. So that's a different way to do these, if you can do that. Nothing wrong with this at all.
So you can do either one.
You know, there's probably going to be times in which you actually have to know how to complete the square like this. It's just not going to be an option to do it other ways. So I do want you to know that process. I do suggest you know it. But let me show you one last way, because I think 2 ways isn't enough. You need 3 ways, right?
Yeah.
All right. So you know what? I'm going to show you that other way.
This
in
is one
conjunction-
way. This is one way.
This is one way. Now,
Okay.
this is what we did originally. We completed the square, and then we were able to look at that and say, oh, okay, 2 and 1, that was our vertex. Here's another way. That didn't involve any work completing the square at all. And with our next example, I'll show you one final way we can do that kind of stuff. Let me choose out a good example for that last one. Let's take a look at example G. So I'll get myself a new sheet of paper here because I anticipate covering it all up. F of x equals 2x squared plus 20x plus 42. Now, let's use the idea that we just did to help us out a little bit in terms of the graph, in terms of finding the vertex. The idea we just did is going to help us if we want to put it in the form of f of x equals a times x minus h squared plus k. Because I know that the vertex is going to be h and k, and I already know what a has to be for this. What does a have to be over here? What would you guess?
1.
Guess again.
2.
2. That's your a.
Oh.
That's your A. So let's see if we can't circumvent that completing the square process. Like I said, disclaimer, you should know that. But if you're on a test and I just say, hey, what's the vertex? You could do this. X equals negative b over 2 times a. So help me out here, please. What's b equal to in this case?
20.
20. All right, so 20, good. And someone else, when I heard from you today. Jay, I just picked on you. Dalen, I picked on you. Jeremiah, what's A for us in this one?
2.
Yeah, perfect. A is 2. So I get negative 20 over 4 gives me negative 5. That is the x-coordinate of my vertex. Okay. I need to figure out what the y-coordinate of my vertex is. Ryan, what should I do to figure out the y-coordinate? Any suggestions? Some help?
Get negative 5 for x.
Plug in negative 5 for x. So I'll plug that into my function, which goes in here, which goes in here. And let's do a little work here. Negative 5 squared is 25, not negative 25, minus 100 plus 42. So it's going to be 50 minus 100 plus 42. I think that gives me negative 8. Is that what you guys are getting?
Yes.
All right, good deal. So in terms of my h and k, I've got negative 5 and negative 8. So I need to put that in here into my formula. Okay, well, I can do that. So that's going to mean f of x equals 2 times x minus negative 5 squared plus negative 8. Oops, that should be negative 5. Does anyone know why I put the double parentheses here?
Because you're subtracting a negative
Yeah, you're subtracting a negative. And what simplification can I get there when I subtract a negative?
addition.
So this is 2 times x plus 5 squared minus 8. There you go. So perhaps a lot easier than completing the square for this one. So we know our vertex, x and y. So our vertex was negative 5, negative 8. That's our vertex. What else can we do here? Well, we can find the y-intercept. We've got choices for finding the y-intercept. You've got two different forms of this function. You've got this one here in orange, and equivalently, you've got one up here in pink. Where is it going to be easier to plug in x equals 0? The pink one or the orange one? I'm thinking the pink one, right? Because if you plug in a 0, that first term 0, that second term 0, oh, you just get 42. So 0 and 42, great. Now this last part, again, we want to find the y-intercepts, excuse me, the x-intercepts. So I'm going to set y equal to 0. If I set y equal to 0, that's going to give me 0 equals 2 times x plus 5 squared minus 8. And isn't this one special? This one's going to work out really nice. Let's move the 8 to the other side. 8 equals 2 times x plus 5 squared. Then what?
Divide by 2.
Divide by 2. And here's the special part, right? Because 4 is a perfect square. I'll take plus or minus the square root of 4 equals x plus 5. The tricky part is that you've got to move this 5 over here as a negative 5. And then you've got to do both of these kind of one at a time. Negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. You can't just wave a magic wand at it and go, oh, plus or minus 3. It doesn't work that way. Let's look at this on Desmos. and just kind of confirm a few things here. On a test, I certainly want to see some work. I'm not giving you points just for knowing Desmos. Looking good. Here and here. So that matches, that matches. Everything's looking good. Everything's looking real good. Couple more things here to kind of finish this one up. So these 4 points are certainly points that I would want. If you're graphing this on WebAssign, it's going to ask you to graph a parabola, I think first by graphing the vertex and then one more point. So this one and maybe the y-intercept. You can get one for free because there should be a point on the other side of your axis of symmetry right here. So, and I'm almost hitting it right. Should be at exactly -10 and 42. Tough to get spot on, but I'm pretty close. What's the axis of symmetry?
X equals -5.
-5, perfect. That line should go straight through your parabola down the middle. Make sure you give me an equation, something you can put into Desmos and have a graph. X equals -5, your axis of symmetry. I could ask you for the domain. The domain is everything, -infinity to infinity. The range is the more interesting one. The range is going to go down to a minimum of -8. And then what's its maximum?
Infinity.
Perfect. So actually that's wrong. I do a parentheses. I should draw a bracket. -8 to infinity. Make sure you go from lowest to highest, left to right or bottom to top, depending on if you're doing domain or range. A couple last things I could ask you would be, where's this graph greater than or equal to 0? So, okay, let me get rid of this for a second. That's just kind of making things a little bit more murky. But where's this graph greater than or equal to 0 is really just asking you, where's the y coordinate above the x-axis? So, where is f of x greater than or equal to 0? Well, it'd be to the right of -3 and to the left of -7. So, -3, -7, basically positive, negative, positive. We want the interval to the right, so -3 to infinity, and the interval to the left, -infinity to -7. Both your finite numbers here get brackets. Since I've got you wrapped in attention, let me just mention one last little thing here, which I think you'll like. Remember at the very start of this, we were completing the square in order to find the vertex. There's another way to find that vertex if it works out nice and easy. That's Desmos. And click right there. And if you can find the vertex that way, it makes it really easy to say, oh, well, h is -5, k is -8. There's my completed square form or version of this formula. So depending on where you're at, what you're doing, if you can do this with Desmos, it could make this process a lot quicker. But I would strongly suggest that you know how to do this, because it's very easy for me to give you a problem in which using Desmos to find the vertex is going to be very, very challenging for you. You're not going to want to do it. So, okay, that's it for this section. I think I do have a little bit more in my bonus video, but for now, good luck and see you.